Alright, so we're going to look at this piece of the study guide. And the first one you're going to use the definition of congruence in terms of rigid motion to determine whether the two figures are congruent and explain your answer. So yes, these two figures are congruent. If you look at the side lengths, you notice you got 3 and 3 and 3 and 3, and you can just tell by those side lengths that they are the same. And you can also look at the angles, but also you look at the rigid transformations here, or the rigid motions, and you notice that this has been reflected, alright, and then it's been translated up, so it's been, the reflection is over the y-axis and the translation is up 5 on the y-axis. Alright, we look down here at the bottom and we see that find DF and measure of angle EDC if the two triangles are congruent. So DF is 32 centimeters because we look at DF here and we notice that 20 and 12 make up AC, in which that is 20 plus 12, which is 32. And if these two triangles are congruent, in which we know that they are by the congruent statement, then DF is also 32 centimeters. And then we also know these two triangles are congruent. A and D are both corresponding angles, so they're going to be both 67 degrees. Alright, we look at number 3 here. Tells us that the two triangles are congruent. We're going to find JK and measure of angle JLM. Alright, so we know that JK is just the same as ML because they're opposite, or they have been rotated. Alright, now so we know that this one right here is 22.9 feet. Alright, we also know that angle J angle JLM, which is always the middle angle. We know this alternate interior, right here to 50. So we're going to say 50. And we know they're congruent, so that has to be the same. And we know that this one's 34, then this one's 34. Alright, we know that's 96. This one's 96. Alright. But we're just looking for JLM, which is 50. Alright. Moving on to the next one. What are all the ways to prove that triangles are congruent? Well, we got side, 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 angle, side, angle, 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 side, hypotenuse leg, and side, angle, side. We know we cannot use angle, 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 and angle, side, side. Alright. To find the distance JK across the lake, you locate the points as shown in the figure. Explain how to use the information to find JK. Alright, well, first of all, I know that JK is congruent to LM, so I know that JK is 160 feet. Alright. We also explain how do we know this? Well, you could look at it as a rotation. That this figure has been rotated 180 degrees, whether it be counter or counterclockwise or clockwise. Also, we can know that they're congruent by, we could think of it as side, angle, side here, because we know that these two are congruent here. They both have the same sides and the same angles and same angle. Or you could look at it as side, 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 because we know that these sides are going to be congruent here, because we know that's 160 as well. Alright, number 6, it says find the value of y. You name the theorem being used. We know that y is 104 by the exterior angle theorem. We just add the two interior angles to find the exterior angle. Alright, number 7. Find the measure of angle K. Identify the theorem used. We got 62 for K, and it's isosceles triangle theorem because we know the two base angles here are congruent. But we're also using the triangle sum theorem to add up all the sides. So also in this, you have to know that they're isosceles triangle when we're talking about the base angles being congruent. But you're using that to prove that the triangle sum theorem as well. Alright. Explain how you got your answer. I set up my equation, added the two base angles and the third angle, subtracting from 180 to solve for K. Alright. Number 8 here, find the length of AB. I got 50 units. I use the isosceles triangle theorem. I set the two side, and I mean this one up top, number 7, is basically the triangle sum theorem, but you have to know the isosceles triangle theorem in order to set that up. Know the properties of isosceles triangles. Anyways, right here, this is the isosceles triangle theorem. We set them equal to both sides because we know isosceles triangles has two equal base angles and two congruent sides. So we set them equal to each other. We solve for x right here, and we get x equals 15. Then I take 15 and I plug it back in, and I get 3 times 15 is 45 plus 5 is 50. Alright. Number 9, in the parallelogram below, find the measure of angle G. So I'm using the consecutive angles of a parallelogram R. Excuse me, not congruent, but supplementary. Alright, R supplementary. So we look right here, we got the consecutive angles equal 180 degrees. So I know I can just say G plus 120, which is G plus F. So I subtract 120 from both sides and I get G equals 50. And I know that G and F are both going to equal 180 degrees if you add them together. Explain how you got your answer. I said G plus F equal to 180 and solve for K by subtracting 120 from 180. Alright, number 10. Alright, we're going to find X and Y here. And we're going to use the opposite sides of the parallelogram are congruent. So we know that the opposite sides of this parallelogram here are going to be congruent because of the theorem. So we know that 12 and the properties of a parallelogram. So that 12 and Y are Y is going to be 12 because its opposite side is 12. And X is going to be 6 because its opposite side is 6. Alright. Number 11. Find the length of the following and identify the theorem used. I know that BD is 18 because I know that this segment, or half a segment of the bisect, is 9, and this is 9. 9 plus 9 is 18, which gives me BD. And I know that EC is 6 here because whenever the diagonals cut each other half, creating congruent segments here. So the opposite side is also 6. Diagonals of parallel bisect is the theorem used. And then the BD, add 9 plus 9 because B is congruent to DE, and E equals 6 because AE is congruent to CE. Alright. Number 12, find the value of X. This is the exterior angle theorem. All we got to do is add together the two interior angles and we get 110 degrees. Alright, number 13, find the measure of J. Right here I'm using the isosceles triangle theorem to understand that these two angles are going to be, the two base angles are congruent so that I can set it up, but I'm also, just like earlier, I'm using the triangle sum theorem. And mainly to solve it, I'm using the triangle sum theorem, but to set it up, I need to know that's also triangle theorem. Two base angles, and then I set up my equation. It's x there. Alright. 14. I'm using isosceles triangle theorem. I got 2x plus 4 equals x plus 18. I solve it, I get x equals 14. I plug it back in for LM here. So I just say 14 plus 18 is 32 units. So I just set up solve for x and plug it back in. Alright, in the parallelogram below, find angle B. Alright, we're using consecutive angles of parallelogram are supplementary. So we set it up, B plus 43 equals 180. So B and A plus A equals 180. Subtract 43, I get angle B equals 137 degrees. Number 16. I know the opposite sides of parallelograms are congruent, so I know that this side is congruent. This side, this guy is congruent to this side. Alright, and that's opposite sides of parallelogram are congruent. Number 17. Find the length of the following. Identify the theorem used. Diagonals of the parallelogram bisect each other. So we're looking for AC, so AC, and I know that AE is congruent to CE, so that's 3 and 3. 3 plus 3 is 6 for AC. And then I look at ED, and we are already given ED, so I just wrote down 9. I just named the side that it is. Alright. And then this is just some additional practice, so I'm going to find the measurement angle K here. And the way I did it, I just subtracted 112 from 180 and got 68 for K. And that's just the consecutive angles of a parallelogram are supplementary. Alright, 19, measure of angle R. Well, that's opposite angles of parallelogram are congruent. And then T, same thing, opposite angles are congruent. And then KR, opposite sides of the parallelogram are congruent. Alright. And then we look at the bottom down here. I find X is 29 degrees here. Alternate interior angles, because there's 29. There are two parallel lines cut by a transversal. That's 29 and that's 29. Alright, and to find Y here, I'm going to use my triangle sum theorem. I'm just going to add 78. And then my newfound 29 here. And then plus Y equals 180. Add together, subtract from 180, I get Y equals 73 degrees. Alright. And then right here, all I got to do is, by the triangle exterior angle theorem, I know that Z is equal to the two alternate or outside interior angles here. And so I just add 73, which is Y, and 29, I get 102. Alright, on my next one, I got find X, and I know it's alternate interior to 31. Alright, and then find Y, I know it's alternate interior to 44. And then I know my side in the middle is congruent, so these triangles are congruent by side angle side. Or excuse me, not side angle side, angle side angle. And so then I know if the two triangles are congruent, then Z must also be 105 by corresponding parts of congruent triangles. Alright, right here, if I'm going to find X, I know X and 73 right here are opposite angles in a parallelogram, so they're always going to be congruent, so X is 73. I know that Z is going to be 107 because two consecutive angles on a parallelogram are congruent. Alright, and so I just subtract and I get 107 for Z. Alright, and then I know that if Z is 107, then this angle right here is 107, and these two are on a straight line. So if you just subtract 107 from 180, you get 73. Or you know that, well, if two consecutive angles are here, for example, if two consecutive angles give me 180 degrees. Now no, if this is 107, this is 73, that make 180. This has, Y has to be 73 as well. Alright, well, good luck on your test.